EMF and internal resistance of a cell. The EMF and internal, they are the most difficult quantities to measure. Why they are difficult? Let's start with the the voltmeter itself. So why can we take help of voltmeter to measure the EMF? That one. These are the terminals A and B. And there's a voltmeter. Any voltmeter what you connect will have internal resistance. Let me call that as R. Then these are the terminals are there. So how what is the purpose of this voltmeter? To measure the EMF of cell. And any voltmeter you take it will have internal resistance. Let the EMF this be. So based on this, a current I will flow. Plus minus, there's a polarity. What is the expression for current? I is equal to, we'll write KVL plus C plus C minus IR minus I into R equal to 0. So what is I is equal to E by R plus R. Then what is the reading of voltmeter? The reading of voltmeter is what? VAB. So can we calculate VAB? So by writing loop equation, VA minus C plus IR minus VB0. So how much I'm getting now? VAB is equal to applied EMF minus I into R. So further this will become, I will be written as E by R plus R. So this will be ER by R plus R, or we can directly apply the potential divider formula. Okay, this is the basic equation. Okay, let's do one thing. This what I got the expression for the terminal voltage. Okay, now what voltmeter reads terminal voltage, no, not equal to applied EMF. You see, VAB was not equal to E, the applied EMF. It is less than. Already we know. So this was the problem with the voltmeter. So when do the voltmeter, when VAB will become equal to E? When current through the voltmeter becomes 0. When this current is 0. So therefore, I should bring such a voltmeter where the current through the voltmeter should become 0. Current through that voltmeter should become 0 means no current should flow to the meter, because what is in turn again voltmeter made up of? Voltmeter is in turn made up of like a galvanometer and a I resistance in series. So no current should flow through galvanometer. No current means the pointer will not deflect. The pointer will not deflect means no way the voltmeter will have a deflection and we can't measure. So that'll be totally ruled out. Means an voltmeter, ideal voltmeter. Can we take help of ideal voltmeter? Yes, if ideal voltmeter, VAB will become equal to E. For ideal voltmeter, what is the internal resistance? R will tend to infinity. If R tends to infinity, then I will be 0. Then VAB will become equal to applied EMF. So is it possible to have ideal voltmeter? If you keep ideal voltmeter, the pointer will not deflect. The pointer will not deflect here. So though we write on paper VA equal to EB, so the pointer will not deflect. This is about the ideal one. Huh? So if you directly go and connect ideal voltmeter in a circuit, so what you get, you don't get any deflection. So altogether, shall I say that if you take ideal voltmeter, we don't get any deflection. If you take practical voltmeter, it will show the if it will show the reading which is less than EMF. So therefore, what is the conclusion? I can't measure the EMF of a cell. Similarly, let me try for internal resistance of a cell. I want to measure the internal resistance of cell. I'm going to take help of this particular formula. R plus R equal to ER by VAB. So this will be further simplification. So the expression will end up like this: E by VAB minus 1 into R. So how to measure the internal resistance of a cell? How to measure internal resistance of a cell? Measure applied EMF, measure terminal voltage by connecting external resistance R. I am directly introducing to the idea of principle of potentiometer. There's a core idea. All the numerical just revolve around the discussion only. Now you see that what is capital R? Capital R is resistance of voltmeter. No, I can bring voltmeter of any internal any resistance. This R is not something, capital R is not fixed. No, for different voltmeter, the value of capital R will be different. EMF of cell is a fixed value. R is a fixed value. So here, as you vary R and E are fixed for a given cell. Then as you vary capital R, what quantity will change? The VAB is going to change. VAB is going to change. So as R varies, VAB varies. So by varying R, you can't change small r. Though mathematically we are writing the equation, but practically what will happen? As you bring different voltmeters, then internals of cell will change. No, not possible. No, this is totally wrong. No, you bring voltmeter of internal resistance, say like a R equal 10 ohm. Then you connect another voltmeter of R equal 20 ohm. Internals of cell will change. No, EMF of cell, they are fixed here. So what will change? The terminal voltage is going to change. So therefore, to measure internal resistance, I'll be using this formula. Then to measure the applied EMF, I'll take help of this particular thing. So now what is accessible? So I'll directly come to the point. Points A and B are accessible for connections. Accessible means any voltmeter what you can connect here across AB only. Can you connect at AC? Can we connect voltmeter across AC? Then I'll measure applied EMF. Then we'll connect ohm meter across CB. Then I'll measure the internal resistance. So not possible. The point C is not accessible. I'm making this one. Point C is not accessible. You can't. It's not possible. So whenever I sell, which points are accessible? Only A and B. So we can't connect voltmeter across AC. Getting this one? We can't connect ohm meter across CB. So no question of measuring EMF and internal resistance by any instrument. Are you getting this one? What you can measure? Only terminal voltage. With that only what happened? We should find out the applied EMF and the internal resistance. Are you getting? I'm just trying to pull you to the core idea. So what you can measure? Only terminal voltage. That's finished. With that terminal voltage only, what all you should find out? The applied EMF, internal resistance. And then how to calculate applied EMF? It's when terminal voltage becomes equal to applied EMF. So when do that condition, when current through the instrument or when current through the cell becomes zero, then the terminal voltage will become equal to applied EMF. So therefore, what is the idea I should use here? To measure applied EMF of a cell, what I should do? I should see that current through that cell should be zero. Then its terminal voltage will become equal to applied EMF. Got the idea? So I'll put it now. So I'll write the basic core idea now. If a current also like the terminal voltage will be equal to applied EMF of cell when current through the cell is made zero. So now how to measure the EMF of a cell? A cell whose EMF you want to measure, see that the current through that cell is zero, then you measure terminal voltage, that will become equal to applied EMF. This is the idea. This idea one, which I'm going to use. I'll construct a circuit where I'll be using this idea. So call this idea one to measure EMF of a cell. Now similarly, to measure internal resistance, what I should do? Connect some external resistance across a cell. This one, what you see here. Connect an external resistance across a cell. You must already know EMF. First calculate EMF by idea one of a cell. Connect some external resistance across a cell. Measure terminal voltage and substitute that in this formula. You will get the internal resistance of a cell. So what is idea two? The idea two is connect an external resistor R across a cell and measure terminal voltage VAB and use above formula. This is the idea two. So all our entire now what all we do, all the problems now just revolves around these two ideas. This idea one, idea two are called as principle of potentiometer. Principle of potentiometer means, what do you mean by principle? Means the core idea that are involved in construction of potentiometer. So now what is a potentiometer? It's a circuit which is designed to measure EMF and internal resistance of a cell. Later on in the numericals, you can see further application. We can go for further. We can measure even the unknown resistance. If you want to find out resistance, we took help of V-store network. I can use even potentiometer to find out the unknown resistance. So now I'll begin with idea one and idea two. First, let me go for idea one. So to construct the potentiometer circuit, what it contains? It contains a standard cell. All of you, I'll just show it once. I'll display. So now you are to ask us, sir, why you are bringing circuit like this? To make